Welcome to the Explainer. Today, we're cracking open the diagnostic toolkit to understand a really critical piece of metabolic health, insulin resistance. We're going to explore the biomarkers that let us see what's actually happening deep inside our bodies.
You know, insulin resistance is often a completely silent signal from the body. You can't feel it, you can't see it, but it represents this fundamental shift in your metabolism. So how in the world do we diagnose it? Well, we need the right tools to translate those signals. Let's dive in and see what they are.
So, before we jump into all the different diagnostic tools, let's just make sure we're all on the same page about what insulin resistance really is. At its heart, this is basically a communication breakdown. Think of it like this. Insulin is knocking on the door of your cells, trying to deliver energy, glucose. But the cells, they just aren't listening very well. The biomarkers we're about to talk about, they're how doctors can listen in on that broken conversation. Okay, so where do we even begin? Let's start with the foundational tools, the ones that have really been the gold standard in clinics and research for years. Meet HOMA-IR and Quickie. These two are the trusted workhorses for checking out insulin resistance. And honestly, the best part is they're both calculated using two super simple measurements you get from a standard fasting blood test, your insulin and your glucose levels. Now, as you can see, both of these tests use the same key ingredients, fasting insulin and glucose, but they process them a little differently. HOMA-IR, with its pretty straightforward calculation, is the one you're most likely to see. It's fantastic for a clear diagnosis. But check out Quickie. Its more complex formula makes it way more sensitive, which means it can spot those really early, subtle changes. And that is absolutely crucial for prevention. But here's the thing. The story of metabolic health is bigger than just blood sugar and insulin. The next set of tools brings another major player into the picture: fat. Right, so these newer indices, they combine different measurements to give us a much more complete picture of what's going on. They're especially good at telling us about visceral fat. That's the really sneaky fat stored deep in your abdomen, wrapped around your organs. And this is a perfect example of how science develops more specific tools for specific jobs. The TILG index, it's awesome for broad screening because it's simple and really accessible. But then you've got VAI and LAP. Think of them as specialized instruments, incredibly effective at predicting issues in tougher cases or for specific groups, like women with PCOS.
And here's another one of those super specialized tools. Adipo-IR gets even more specific. It's not just looking at fat in general. It zeroes in on one very specific question. Is your fat tissue actually obeying insulin's command to stop dumping fatty acids into your blood? Catching that malfunction early is a really big deal.
So you can kind of see where this is going, right? The natural next step was to ask, hey, if combining a couple of data points is good, what if we combined even more? And that led to these powerful all-in-one scores that give us a truly holistic view. Yeah, don't think of these as single tools anymore. They're more like advanced diagnostic computers. They take a bunch of different inputs from your blood work and body measurements, run them through an algorithm, and spit out a single, highly predictive score. So here's the crucial point. A score like METS-IR looks way beyond just glucose and insulin. By pulling in triglycerides, your good HDL cholesterol, and BMI, it builds this much richer profile of your metabolic health. It's so effective, it can help predict not just insulin resistance, but your future risk of cardiovascular disease. And if METS-IR is like a powerful computer, then you can think of FLAIS as a high-precision laser. It goes even further, integrating a whole array of parameters. Things you might not think are linked to insulin, like red blood cell counts and liver enzymes. This creates an incredibly detailed picture. Because it's so complex, it's not something you'd get at a routine checkup. Now, this is more of a specialist's tool, used to detect insulin resistance in people who might otherwise look perfectly healthy, catching the problem at its absolute earliest stage. All right, for our final section, we are heading to the absolute cutting edge of this research. And it's looking at a place that might totally surprise you: the trillions of microbes living right inside your gut. This quote you're seeing, it is a potential game changer. It suggests that the health and the makeup of our gut bacteria are directly linked to our metabolic health. The conversation isn't just between our hormones and our cells anymore. Suddenly there's a third party involved. So what does this mean for you? Well, it means that in the future, a diagnostic test might not just look at your blood. It could analyze your gut microbiome, looking for shifts in key bacteria or the byproducts they create. This could lead to a truly personalized metabolic risk assessment. It's pretty amazing stuff.
So at the end of the day, the real power isn't in any one single tool. As we've seen, from the classic HOMA-IR to the complex FLAI-S and these futuristic gut markers, the key is integrating all of them for a complete panoramic view of a person's health. That's what allows for truly individualized care.
And that's our explainer. It really leaves us with this incredible thought that the future of metabolic health might be far more personal and way more complex than we ever imagined. The answer to one of our biggest health challenges might just be hiding in our gut.